All right. Welcome to the speed run. I'm going to be just going through some of these problems for the next like 10, 15 minutes until I get it done. And hopefully we'll be able to have some, progress. Here we go. In the United States, 13 out of 20 cans are recycled. So 13 out of 20 cans. So every 13 cans, every 20 cans, there are 13. What percentage of that? Well, first we can go ahead and we can just do this, and then we take this 0, then we say 3 times 0, and then we say 20 times 3, and then we say 1 times 0, and then we have 1 times 20. And then we have 0, and then we have 60, and then we have 0, and we have 20. So that goes out there. I feel like that wasn't it. And then we have 1, 2. We have 1, 2. So 12 out of, no, yeah, let me see, 12% of 20 12% out of 20 is, no, wait a second. Yeah. Okay, so 12% out of 20 is 13. Well, let's say, what is 10% out of 20, right? That would definitely be 0, 0, 1, yeah, 0, 0, 0, 2. And we have 200 as 1, 2, and it would be 20. I feel like that's wrong. And then you have 20. Yeah, so you have 20 over there. And I know that 10 out of 20 is 50%. And you have 10 decimal. Oh, I know what I do this. Because that's the whole issue. Because you have 10, and that's not how it was supposed to be. If you want to say 10 out of, we have to basically do it, we have to go ahead and do the division first. So 1 goes into 10 2 times, and then we say 1 goes into 10 2 times, and then we say, yeah, and I think that would be it, right? Because basically, you would say 50% of the cans are recycled, but we're not getting that over there. Oh, I think I got it now. It's the other way. So it's 20. How many times does 20 goes into 0? 0 times, Then we put the dot, and then we put the 0 back here. Then we put the 5. That's how we do it again. See? Great. And that's where I want to go ahead and like pay attention to. So I was doing the division wrong. Like it's the other way around. I'm not able, it's not intuitive to kind of use the division that way, but it does make sense when I draw it, and putting that in, that idea is great. So now we know that. Now we could just do the same thing for this number. We could say 20 goes into 13. So when it says 13 out of 27, it's not this. It's actually this. So we go 30 goes into here. We say 0 times. We bring a 0 down here. Then we go ahead and say how many times does 2 go into 6? I mean, 2 goes into the 130. We know that the maximum amount would probably be 6, because 7 is 440. So then we would say 6, right? And then we bring this down here, and then we try to say, oh, how many times is 2, how many times is 20 goes into to 10? And we would say 0, and we'll bring a 0 down here. And now we would say how many times is 20 goes in here, we say 5. So then we can say 5 times 20 is 100. Then this will be 6,500. Then we do the 1, 2, 65%. Okay. So now we have this other problem. We have Mrs. Conley asks her class what kind of party they want to have to celebrate their excellent behavior. Out of all of the students in the class, 5 want an ice cream party and 7 want a movie party. 10 want a costume party and the rest are undecided. So then we say, if 20% want an ice cream party, how many students are in the class? So then we say, so we go ahead and we can, remove this because I want to see the numbers. And let's remove this too so that we can see the numbers. So if we know that in the class, out of all the people in the class, 5 want ice cream, 7 wants movie party, and 10 want a costume party. And the rest are undecided. So we don't know what those people are. So we go ahead and we say 20% want ice cream party, right? So we know that we know ice cream is 20%. And then you know that what do you call it again? We don't know the other movie thing, but we know ice cream is 5. So we know 20% is 5. That's one thing that's good to know. So if we see 20% of the class equals 5, that really helps a lot because now we know 80% is just 20 plus 20% plus 20% plus 20%. And then that's 5, 10, 15, 20, 25. So we can probably guess that the entire class now it's not 25%. It's actually 25. So that's great. So now we can say how many students are in the class. So now we can say 25%. So the other pieces here weren't even necessary. That was the key. The key was the 20% and the students in the class with 5 is ice cream. So we know. So now we can try that and see if we get it wrong. Nope, we got it right. All right, and we move on to the next one. Next one is this is Emily's family loves to work together in the garden. They have a slight preference for flowers. Of 60% of their plants are flowers. So we can say flowers are 60%. And plants are 40%. No, I think I read that wrong. Preference for flowers as 60% of their plants are flowers and 40% are vegetables. So we're gonna so it's basically vegetables. They're all plants. And it says they have 50 plants growing in the garden. So we know a total of them is 50. So then it says here, how many vegetables do the plants have? Well, we know that percentage is basically a fraction of a whole, a single whole. So it's 100. So if we add up 60% plus 40%, we get 100%. So then they say they have 50 plants growing in the garden. And now we know. So now we have the 50%. Now we know that the total amount. This is the total amount. If you want to look at a graph, you can. It wouldn't really be that way. It's kind of be something like this. Yeah, where this would be flowers, and this would be vegetables. Sorry for the handwriting. I'm just gonna take this out. I try to tell myself that I don't like when my teachers like, I'm trying to say V for vegetables, and we're gonna say F for flowers. And it says here that it's how many vegetable plants do they have? It says vegetable plants. So we want to basically take the vegetables and we want to take the 50 of this. So we don't know the actual amount. All we know is there are 50. So we got to first find out, we know 50 plants equals 100. So now we can go ahead and we can say 40. Do the 40 here, and then we're going to times it by 40 times by 50. No. Oh, I thought it was going bad. Yeah. So you have this one. And then you have 20. And having like a brain fart right now. I'm trying to. I know that we know that 50 times 50 would be 250. So we know that 50 times 40 will equal 200. So if we know that, then we know that we want to move this back. We know that 40% would be 20. 20, that's 20. And then if 40% is 20, that means the 20 more would be 40. So we can look at it like this: 1, 2, 3, 4, 5. So yeah, I'm just gonna skip that and just go to 20 plants. Kind of run speed run, right? Speed run. Esteban has a big jar of change in his room. He has 600 coins total, 600 coins. And then 240 of them are pennies. So we know that pennies in America mean 1 cent. That's what it is. And USD means United States dollar. Okay. And it says, what percentage of coins are pennies? So we can just subtract that real quick. We're going to just put this 0 here. We're going to bring this down to 5, get a 10 here, bring a 60 here. Then we're going to just subtract 5 to 360. So the rest of them are 360 coins. So we remove the kids. So if we had a jar, yeah, the jar had coins in it. I don't know. I'm just gonna just store it over here. We're gonna you're putting the coins over here. All the pennies are gonna go over here. Fun fact. 240 is actually 2,040 cents. But we won't really boast about that right now. So what percentage of the coins are pennies? So now we want to just take that. We want to figure out what we were doing before. So we were doing. I remember when we were saying how many. It was like something. The first question was about there are something about, I forget, coins or cats. I don't know. It's cans. I don't know. Anyway, we're going to do 360 into 440. But since we have the zeros here, we're going to use the 360. I mean, we're going to use 36 into 40 because that's probably easier to do for me. And then I'm going to go ahead and say how many times does 36 go into 24? 0. Dot. And we put the 0 down here. And then we say how many 36 goes into 40? 240 here. Well, we're going to go ahead and we're going to just eyeball it a little bit. We know 6, 12, 18, 24, right? Meaning this is 3 times 4 is 12, it's 14. That's a lot. That doesn't really sound like that's not it at all. That can't be it. Yeah. Look, I was seeing 100, seeing 124. It's 144. That sounds more accurate. So, if you went ahead and redouble this, you would have 288. So it's not going to be that way. So it's probably going to be. Let's go ahead and. I'm actually gonna go ahead and do something really quick. So 3, 6, 9, 12, 14. I mean 3, 6, 9, 12, 15, and then 18, 22. Yeah, 24. Right. That's what I do. So we know that 8 times 3 is 24, right? And we also know that 1, 2, 3, 4, 5, 6, right? That's 6 times 6 is 36. So if we had 80, if we had we have 34 right here. Let's just add these a little bit more. Let's say 36 times 2, right? So 72. If we add 34 times 72, 7, 8, 9, 10, 11, and 6 to 16. And I think that would probably, that's it, because after that, it's going to go over. Yeah, so 2, 16. So we know we have 4, 5, 6. So we know 6 times 36 will give us 216, which is the most that we can go into. So 36 goes into 246 times. And then we use this, we put the 216 in the bottom, and then we subtract that. We're gonna just really go real quick. We have 24 right there. And we do the 0 thing again, and we can notice that it's pretty much the same thing. We're gonna just do a 6 again. And there you go. 216. So you can see that it's actually growing, like the active, but it's pretty much, that's actually what it is. I just want to make sure I'm doing it right. Yeah, that is right. So, it's repeating. Is it? No, there. All right, so let me go ahead and see what happens. Oh, I get it. What I did here is I actually found out how many coins there are 66 coins in there, and it was actually the other way around. So 240 pennies. How many pennies are in here? And that would basically be something like that. Well, it would be 0, and then you would bring another 0 over here, and then we would say 240 times 4. So I'm just gonna go ahead and just grab this and move on this one. 40%, yeah, 40% of them is pennies. So 40 to get 6 coins, yeah. It's, all right. All right. It's up to 20 minutes. I'm already out. I'm already out of time. Yeah, so I'm gonna end it, and I'm gonna come back to that in the next show. I mean, because I don't want to keep going on and on and on. I just want to kind of use this time to kind of just elaborate on it. I have to break down the scenarios of how it's done. Word problems. It's always something you gotta really pay attention to wording. And I used to be in a rush, but this is not a rush for me. But I have other work to do. I have real homework to do. I'm gonna do that. And tomorrow I will continue this. So thanks a lot, and see you guys in the next video.